Click the bell icon to get latest videos from Ekeeda.
Hello friends, and today we are going to study a new topic, which is a frequency shifting property of Fourier transform. So first of all, we'll see the statement and then we'll go on to proof. So first of all, a frequency shifting property. If the Fourier transform of x of t is represented by x of j omega, then Fourier transform of x of j omega naught t into x of t is transformed into Fourier domain and expressed by x of j omega minus omega naught. Now, this is the statement that we are going to prove. So, let's see the proof. Now, we will derive our property but by using a definition of Fourier transform. So, first of all, we'll write the definition of Fourier transform. So, the definition is f of x of t, that is Fourier transform of any continuous time signal x of t is represented by x of j omega, and the definition is integration limit minus infinity to infinity x of t into e to the power minus j omega t into dt, which means we are going to integrate this whole product with respect to t over the range from minus infinity to infinity. Now, what is next? We will use our input function or the statement function. Now, what I have done, I have substituted my whole x of t or input term over here. That is, this whole x of t is replaced by my x of t e to the power minus j omega naught t, which is mentioned over here. Now, look at here, my x of t is in pure form, so no need to change this x of t. But here, we have two exponential terms. So, now what I am going to do, first of all, I am going to add the powers of exponential term. Now, look at here. After adding, you will get this equation. But what I'm going to do, I'm going to take minus jt and minus jt common from both the sides. So I will get e to the power minus jt omega minus omega naught inside the bracket. But if I consider this is nothing but my omega, then I can say that e to the power minus j omega t dt and x of t is nothing but my definition of a Fourier transform. So we will use a definition of Fourier transform over here. So according to definition, if I consider omega minus omega naught is my omega, then I can say that it is nothing but the definition of Fourier transform. So I'm going to write x of j omega, but I will resubstitute that omega value, which is omega minus omega naught. And this is nothing but the definition of a frequency shifting property, or you can say that a proof of frequency shifting property. Now we will study the next part, that is, if here the omega naught value is positive, or we can say that we have advanced the frequency by omega naught. If we add omega naught, or if we multiply x of t by plus j omega naught, which is in the power of e. But suppose if we do the reverse process, that is, if we are going to find out the Fourier transform of e to the power minus j omega naught t into x of t, then the result will be, so this is nothing but the frequency shifting property. So we will study a new property in next video. But for that, stay tuned to Ekeeda and subscribe to Ekeeda for further more videos. Thank you so much.